dead time between the classes. First thing I'm going to do is to erase so I can draw it all over again. It's not, really just the content on the whiteboard, because, the easy thing for me to do is to leave it on the whiteboard, and then I can just say, oh, okay, just look at that picture and so on. But I want to go through the process of drawing that picture because it really is the process that is important, not the final product. Okay, it's the journey, not the destination, right?
Sound like my mom.
Well, I used to drive a Miata, so I fully understand the concept. I don't want to get to the destination at all.
Or when a good song plays on the radio.
As long as somebody is paying for gas,
get a
I'm
couple
good.
red lights.
With a Miata, you can't really hear the music either way. I have a bass speaker immediately right behind me, and that way I can barely hear something. I call it my kidney stone buster. Because it really is right behind the seat, where my kidneys are. So let's go over the homework assignment first, because that's one thing that I forgot with the previous class until somebody asked, Tech, did we go over the homework assignment? That's right, I have to go over the homework assignment. All right, so that's the first thing we'll do today is to go over the homework assignment that's due 2 minutes ago. And that one is about conditional statements. So we'll take a look at this one. Here is your conditional statement, and then we'll go ahead and take a look at traces of this one, because there are 3 traces corresponding to this one single algorithm. Okay, here's the first trace. On line 1, we have to evaluate the condition. The condition on line 1 is x is less than or equal to y, so we have to repeat that portion in comments and say x is less than or equal to y, but then we have to also indicate the result of the comparison. Is it true or is it false? False. It is false. Okay, x has a value of 4, y has a value of 2, so the condition is false. Then where do we go when the condition is false?
Line 4.
Line 4, that's right. We do not trace line 3 because we talked about that in class already, that the else does not do a single thing, so we don't trace it. On line 4, it is an assignment statement. The assignment statement says the right-hand side is y. Y has a value of 2 at this point, so 2 is copied to the variable z. Z now has a value of 2, and then we get to post, because there's nothing after the conditional statement, and line 4 is the only thing we have to do inside the else branch. So that's why once we're done with line 4, we get out of the branch, we get out of the conditional statement, and there's nothing after that, and that's why we get to post. Are there any questions about the trace up to this point? Yep.
Does it matter if we put post in the comment section, or do we have to do it in the...
I would like to see it in line number, but if you have it over here in comments, it's okay this time.
Okay.
Okay, trace number 2, which is on sheet 3. We are starting on line 1 again. Evaluate the condition x is less than or equal to y, and we have to indicate whether it is true or false. It is true, okay. And then where do we go?
Line 2.
We go to line 2. Line 2 is an assignment statement. The right-hand side is x. X has a value of 2. We copy that value to z. Z now ends up with a value of 2. And then where do we go? Post. That's right. All right, so that's the second test case. And now we have the third test case. We start with line 1 again. X is less than or equal to y is
True.
True, because 2 is less than or equal to 2. So now we move on to line 2. We copy 2 to z,
Post.
and then we get to post. That's it. That's your homework assignment. Are there any questions about this particular homework assignment? No questions? Yep, go ahead.
Is it wrong? Would it be wrong to put 2, 2, 2?
You can copy the whole thing. That's fine. This is the minimum that you have to do.
Okay.
But if you want to add additional stuff to it, as long as it is not inconsistent with my solution, it will still be okay.
Okay.
Yep. Any other questions? Okay, if there are no other questions, we are done with the homework review. We still have one homework that is due on Tuesday, so don't forget about that one. All right. So we are going back to topic 2, and I'm not sure how much of a repeat until loop we have gone over. So let's go ahead and just start with that one. So we'll go to the loop document, and then we'll get to repeat until, and we'll just skip all the way to the picture first because I want to show you the logic of a repeat loop. We talked about this already?
Yeah,
Okay.
yeah.
So what we're going to do next is we'll trace it. Okay? I don't think we have gone through a trace with a repeat loop.
We did.
We did?
Yeah.
I think I'm
It was the
81.
yeah,
And
the
then
1,000.
X is equal to 80, or X
Oh,
is
okay.
aligned to 81.
And then
Then he did divide it by 1/3.
Okay. But that one is not a tricky one. Okay? So I'm going to show you guys a tricky case where the behavior of a while loop, a pre-checking loop, is going to be quite different from the behavior of a post-checking loop, which is a repeat until loop. So we will basically do a compare and contrast with those two different types of loops. So that will be the next thing to do. I'm going to close this too. So I'm going to exit all the way out and then redo the whole thing because I want to go through, basically use the same example, but I want to do it in class. I don't want to just, put up the document without, actually constructing it from the beginning. Okay, so here I can pick a different value. So let's say x starts with a value of 20, and this is a while loop, it's a pre-checking loop. So we'll take a look at the behavior of a pre-checking loop first. And it says if x is less than 5, for instance, inside the loop we'll say x gets x plus x. And end while. Give it an indentation and line number. So we'll go ahead and trace this one. It's going to be a really short one, short trace, because it doesn't have a whole lot of lines to execute. All right, so we'll put up the header of each column, comments, line number, and x. X can start with an unknown value because on line 1 we are going to overwrite it anyway. On line 1 we overwrite the value of x, x becomes 20. On line 2 we evaluate the condition of the loop. X is less than 5 is?
False.
False. Okay, very good. So do you guys still remember what we do when the condition of a pre-checking loop is false? What do we do?
keep dividing until you get it.
Sorry?
Exit.
Keep dividing until you get it under 5.
But it's already false. So what do?
Proceed to the next line.
We get out.
Yeah.
Yeah, we get
Exit.
all the way out. So we exit the loop, and is there anything after the loop? Nope. So that means we get to post right away. But what about that line on line 3? Well, we don't even use it once because
Not necessarily.
that's the whole idea of a pre-checking loop, because it is checking the condition before we perform the operation. If the condition is false to begin with, we do not perform the operation even once. Okay? In other words, we can perform 0 iterations in the case of a pre-checking loop. Now we're going to look at the code of a post-checking loop, but in many ways resembling the logic of the pre-checking loop. So in the post-checking loop, we'll make the program almost exactly the same. X gets initialized to 20. We say repeat, x gets x plus 1, x plus x, until x is greater than or equal to 5. Because remember, the logic of the condition has to be reversed, because in one, we are stating what condition do we use to stay in the loop. The other one is stating when do we get out of the loop. So that's why we have an inversion of the logic of the condition. Okay, so this is my pseudocode, and I want to trace it in sheet 4 in this case. So we have comments, line number, and once again variable x. Once again, we don't care about the initial value because we're going to overwrite it. On line 1, we overwrite the value of x to 20, just like before, and then we do not trace line 2. Okay, when we have a repeat until loop, line 2 is not traced because it doesn't do anything. It's only here because visually we need to be able to tell where is the starting point of this repeat until loop. So it's kind of the same thing as open quote in English. So when you talk about something, you don't pronounce the punctuations, right? You don't say period, comma, all that stuff. So when we trace an algorithm, it's the same thing. If a line doesn't do a single thing other than visually it is there to separate something or to terminate something, then we don't trace that line. And that's why we don't trace line 2. We skip all the way to line 3 in a trace. What? Wait, hold on a second here. Why line 3? X is already greater than or equal to 5, so why are we on line 3?
Because we haven't gotten to the fourth step yet.
Because that's the whole point of a post-checking loop. Post-checking loop means we check only after we perform an operation. So in this case, we don't have a choice. We perform one iteration first. So that's why we have to get to line 3, even though the condition is already true at this point. We don't even know, as far as the program is concerned, we have not evaluated the condition of line 4, and as a result, we do not even know that condition is true already. Is that making any sense? The only reason why we as people would feel kind of confused is because we scan through the program and we kind of visually eyeball and look ahead and say, oh, line 4 has a condition to evaluate and it's already true. But the program doesn't know that. The program is just going to say, I'm going to move on to line 3 right now, and the condition has not been evaluated yet. So on line 3, we're going to double the value of x because 20 plus 20 is 40. We store 40 back into x. Then we get to line 4. At this point, then we say x is greater than or equal to 5 is true because that's the exit condition. That also means that we don't have anything else to do because we're getting out of the loop. But that's the behavior of a post-checking loop instead of the other one is the pre-checking loop. And you can see the difference doesn't seem to be that important because one performs 0 iteration when the condition is false to begin with. The other one performs at least 1 iteration even though the condition is true to begin with. Do you think that 1 extra iteration is important?
Yeah.
Absolutely. Okay, depending on how the context of that 1 extra iteration, it can crash a program. It can crash a C program in your next class in cisp300 in a way that cannot be explained in the C class itself. Okay, to understand why your program is crashing, especially in conjunction with the use of arrays and pointers in your next class, you will have to wait until cisp310 assembly language programming to truly understand why that one extra iteration can cause your program to crash. Okay, so that's kind of like a look ahead into the next 2 classes that you'll be taking. Okay, but that 1 extra iteration is important. So the question now is, which kind of loop should I use? Well, I can answer that question with a general suggestion. Most of the time, you want to use a while loop. Most of the time, you want to use a pre-checking loop instead of a post-checking loop. But there are cases where a post-checking loop makes more sense, and I'll give you one example. The example that I'm going to give you is representing the logic of asking an end user for a zip code, and you're not going to let the end user go until the zip code is valid. Okay, is that making any sense?
Mm-hmm.
Okay, so the logic to represent that is to say repeat ask end user for a zip code, and we'll just call it z as a variable so that we can refer to it in the until line. So we say until z is validated. Until z is validated. Okay. Is that making any sense so far? Now, I'm not going to get into the detail of how do we interact with an end user, and I'm not going to get into the detail of how to validate a zip code. I'm just going to say that, yeah, we know how to do that, but those are details. So we're focusing on the logic of this code. It makes perfect sense because you have to ask an end user to input a zip code at least once to have a zip code to validate. Does it make sense? Okay. So if we try to implement something like this using a pre-checking loop, then it doesn't make sense, because the pre-checking loop would look like this. It would basically say while z is invalid, do ask end user for a zip code z and while. That doesn't make any sense, because when we get to line 6 the first time, what am I trying to check for validity?
The zip code that is yet to be inputted.
Exactly, the zip code that is yet to be inputted, which means it is not initialized, or at least it's not the content that the end user specifies. So I'll be trying to validate something from either random memory locations or from the previous time this code was run. Okay, but that would not be the intended content that I want to validate. So that's why in this case the while version does not work, because we are trying to check something that is yet to be initialized. And that something, the action to initialize the something that we want to check, is actually something that we want to do over and over again, potentially. Okay. Somebody's going to say, but that's easy to fix. All I have to do is to copy and paste the content of the loop out of the loop itself, so that we can now do it at least once, and then we get into the same thing as a while loop. That is okay. Okay, that actually quote unquote fixes the problem. But now we have a problem because I just used the copy and paste method in this program. Now in programming, every single time that you use copy and paste, you have to ask the question, is there a better way to do it? Well, what is the big deal of copying and pasting one line? I mean, well, copying and pasting one line may not be a problem, but the approach of copying and pasting is by itself a problematic thing. Because if you are used to copying and pasting one line, then you'll move on to 2, 5, 10, 20, 50 lines. So what is the problem of copying and pasting 50 lines of code?
Only one of them needs to be slightly off from what you need for it to malfunction or crash.
Okay. In other words, what if the copy or the original one that you copy had a flaw in it before you paste it? So the one that you pasted, the clone, would also have that flaw, right? Now, when you debug your program, will you remember to fix both versions?
No. Chances are you won't.
Chances is that, if you only have 2, maybe you will. But if you have 20 of copies of that code floating around, it's very unlikely that you can find and fix all 20 copies. So the general approach of copying and pasting can lead to problems like that. It's a maintenance issue. And the problem of maintenance issues is I cannot teach the importance of those things, because your programs will only be up to maybe 300, 500 lines of code at the most, and you won't run into those problems until you're dealing with much larger programs. And if you own a company, like a software company, and you have to maintain anything that is significant, significantly complex, like Flappy Bird, I'm just checking to see whether you guys are still paying attention. So in those programs that are relatively large, and you have can use the copy and paste approach all over the place, the program becomes really unmaintainable in the future, because if you locate a bug, then it's hard to fix all of the copies. All right, so now that this one is discussed, it's time to move on to the next thing. The next thing has to do with, we are basically done at this point. Let me just kind of go back to Moodle first. We are currently at this point, okay? We're done with loops already. As far as control structures are concerned, we are done. In other words, we have assignment statements. Okay, first of all, we have variables, okay? Variables are basically things, or constructs in a program where you can store a value, and you can also refer to its value, okay? It's just a place to store something. And because of variables, we have assignment statements. Assignment statements is the only mechanism that we have talked about up to this point that can change the value of a variable. Is that okay? So that's the first kind of statement that we talked about. And then we talked about conditional statements. You have a branch, you can take one of the two branches, but the two branches have to merge at the end. But that cannot give you the ability. It doesn't give you the ability to do something over and over again, which is very useful. So that's why we talked about pre-checking loops, the while loop, and post-checking loops, which is the repeat until loop. So we have a mechanism to do something over and over again. So altogether, and also implicitly we talked about sequences, which means if you have a bunch of, let's say, assignment statements, you execute those statements from top to bottom in the order that is specified. But that's kind of implicit. So now we have all of the control structures that we normally find in any programming languages. The other ones, like switch statements, for statements, and so on, they can usually be emulated using one of the things that we have talked about already. So as far as this class is concerned, we are done with control structures. So are we done? I mean, we are 4 weeks into this semester.
Finished. Business goal.
Are we finished? Well, not quite, right? We are not even close to finish, because those constructs are fairly simple. Each one is fairly simple, okay? And we have to learn how to combine those constructs to actually make something that is useful, to create algorithms that are useful. So we are now moving on to nested statements, which is one way to combine the statements into more complex structures. Now, the entire module, the module 40, which talks about nested statements, the first thing I want to do is to explain why nested statements are important. And that sometimes, just explaining the rationale of a particular feature in programming can be difficult. This one is not. This one is pretty easy to explain. How much do you pay for a 2 or 3 terabyte hard drive these days? $100 or so? 70? Okay. So for $100, I suspect some people can buy a 4 terabyte hard drive now. Thereabout, maybe a little more than 100. Okay, but not by much. Not by much. So it's really quite interesting how mass store, or the capacity of mass store, has increased over time. When I first started teaching this class, just measuring things in hundreds of gigabytes was like, wow, that's a lot of storage. I mean, hundreds of gigabytes. And now it's in multiples of terabytes. Okay, and 1 terabyte is 1,000 gigabyte, which is quite a bit of storage. So, how many pictures have you guys taken ever since digital cameras came out? Tens of thousands, probably. Okay, I would not be surprised if it's at least tens of thousands. So, if I pay for a 4 terabyte hard drive for you guys would go like, yay, that's good. But what if I have a string attached and say that on this 4 terabyte hard drive you cannot have subfolders? you have D:\\\, that's it, okay? One folder. And you have to put all your content into that one single folder.
Uh-huh.
Type of demon are you?
Would that kind of make your drive, not as useful anymore? Even though it's a 4 terabyte hard drive, you have all that storage.
Yeah, a lot of clutter.
It will be difficult to find one of the tens of thousands of pictures that you put into that one single folder, along with all the movies and whatnot that you have, on that one single folder. That is the reason why we have nested statements. Because how do you describe folders within folders within folders? They are nested. Okay, you have one folder inside another folder inside another folder. It is nesting. The other thing that we encounter all the time that is also reflecting nesting is the use of parentheses in mathematics, in expressions, right? You use parentheses all the time, and that indicates nesting. What do you have to do first, and then the result of that is utilized in the next operator, and so on. And structured programming is just that. Okay. So nested statement is very important because the next class, most of you are moving on to cisp 360. What is the title of cisp 360? Does anyone remember? I'm not going to press the enter key just yet because just pressing the enter key would get the answer. Is it C++ programming? No, it's not. The title is not language specific.
Data structures?
It's not data structure. It does have structure in it, but it's not data structure. Structured programming. Yep. So you're Pretty close. Okay, so when you look at the catalog, and you go to CISP360, the title of CISP360 is Introduction to Structured Programming. C and C++ is only a vehicle that we use to teach structured programming. We could teach the same thing, structured programming, in Java. We can teach the same thing in Pascal. We can teach the same thing in Python, Perl, PHP. All of those programming languages support structured programming. So what exactly is structure in the context of programming? Being able to have a construct within other constructs. Nesting. Okay? That really is the whole point of structure. And that's why we don't use flowcharts in this case, in this class. Because flowcharts do not encourage structured thinking or structured programming. Has anyone seen a flowchart that is really kind of complicated? No? Okay, I can show you one. I mean, flowcharts are, there are tons of pictures, online of flowcharts that are really kind of complicated. So we'll go to Google and then we just search for, say, complicated flowcharts. And right off the bat, we see something.
That I would not.
That would be a good one.
Complicated, but still follow the other ones.
Immigration roadmap. Find your way to green card. Okay.
Made by a Republican.
Okay, so that's. Sorry, go ahead.
No, it's like they don't want people to agree.
To get a green card, right? This is complicated. Does it look structured to you? In other words, do you see the kind of structure that you see when you see your files inside a folder, files inside another folder, but the two folders are subfolders of another folder, and then that folder belongs to another folder, and so on and so forth. So it's easy to find things, right? Okay, I want to find pictures that I took in year 2008 around the summertime. Okay? If I have folders for the year, and then within that year I have folders of subfolders of each month, it will take me like three clicks to get to all the pictures that I took in that month. Now within that month, if I organize by trips and whatnot, I can even go further and locate the 400 pictures that I took during a trip. And if I go organize that even more, organized by people pictures, versus sceneries and stuff like that, I can even get to my picture of a waterfall even quicker, right? Does this look like there's any easy way to find something? No. The answer is no.
Start.
Yep, exactly. So now looking at this picture, which is not structured at all, okay, and you tell a programmer, okay, so let's say a systems analyst came up with this picture and say, okay, we want an information system that can guide someone through this process, and turn this over to a developer. What do you think the developer is going to do? That, okay? Because this is difficult to translate into an actual program. Okay, something that looks like this is really hard to translate into actual programs. It's not like it's not possible, but it is very difficult. Now, the reason why it's difficult is because most programming languages support structured programming, right? And that's a way to organize a program so it's easy to follow, easy to specify, and easy to find bugs. This does not lend itself to structured programming. So that's why I don't personally like to use flowcharts, and I really believe flowcharts should stay simple. For any logic that you can use up to maybe 10 little bubbles or whatnot, you can probably consider using flowcharts. Something like this, not a good idea. All right, so getting back to structured programming, which is here, that basically covers the why part, okay, the rationale of structured programming. So what we want to do next is to come up with an example of structured programming. Now, what do you think leads to programming, or leads to the process of being able to specify code so that the computer can do it? What is the title of this class? The prerequisite of cisp360, right? And what is cisp360? One of the classes I have to take to get my computer science transfer degree, right? But what is the title of this class? Algorithm design and problem solving, right? Okay, so that means we have to be able to solve a problem first before we can program or write an algorithm to do the same thing. Does that make sense? That in order for you to write an algorithm to solve a problem, you need to know what to do first to solve the problem. Okay, all right. So let's think about that, and we'll go back to the old problem that we had before. You are given 3 variables, w, x, and y. Okay, and you're supposed to find the maximum of the 3 and then store the maximum in the 4th variable z. Does that sound familiar to you? It should sound kind of boring at this point, right? And this is not the end of that either. We'll keep referring to that example over and over and over and over again, but in different context. So we use something that is familiar to us already to talk about something that's new. Okay. Last time we solved the problem using 2 things. We use a multi-branch conditional statement that has 3 branches. 1 branch for w, 1 branch for x, and 1 branch for y. We also use the concept of conjunction. So the condition of each condition for each condition of the multi-branch conditional statement is a conjunction. W is less than or equal to x, and w is less than or equal to y. So the and is a conjunction. So what if I don't want to use that? What if I want to stick with a conditional statement that only have 2 branches, if else, okay? What if I want to stick with conditions that do not have conjunctions or disjunctions? Just a simple comparison. Can I still solve that problem? Well, let's take a look. And that's why we had a picture earlier, because that was used to illustrate this very point. So I'm going to look for my marker.
Try by the eraser.
Oh, okay, right here. And so we'll start with a conditional statement. Any conditional statement, even multi-branch conditional statements, start with a single branch. And every branch only has 2 alternatives, okay? Because a condition can only be true or false. And that's why you only have 2 branches out of a conditional statement. Okay, so this is the beginning of a conditional statement. And I'm going to make this side kind of big. And same thing with the other side. All right. What does this picture look like to you? Does it resemble one of the control structures that we have already talked about? What is it? It's a single conditional statement, okay? We have if condition, then something to do, else something else to do. But the 2 branches will merge at the end and then exit. So it should be fairly familiar to us by now, this picture. But since I can only compare 2 variables at a time, I'm just going to pick w versus x. Now, this comparison by itself is not going to solve our problem because it can only compare 2 out of the 3 variables. But the result of the comparison is still useful to us, because if it is true that w is less than x, can w be the maximum now?
No.
Nope, because it is less than one of the other 2 variables, and as a result, w is out of the race, right? On the other hand, if w is greater than or equal to x, can I say, well, let's not consider x anymore?
Yeah.
Yeah, we sure can. Because if w is greater than or equal to x, it means w is either greater than x, which means, okay, we don't have to think about x anymore, or w equals to x, which also means we don't have to consider x anymore. Because if we consider just w, and because w is equals to x, that's the same thing as considering x. Is that okay? Okay. So on this side, if you want to label or annotate it, you can basically say we now only have to consider x versus y being, one of these can be the maximum, or both can be the maximum. On the other side, you can say, okay, it's now between w and y, because x can at the most be the same as w. So as long as we consider w versus y, we're still okay. Is that okay so far? Now, what do we do on this side? Before we talked about the possibility of being able to have a conditional statement within something else, if you can only have assignment statements here, then there's no way to solve this problem.
To nest it?
Hmm?
Do like a nest?
Yep. But now that I have just talked about the concept of nesting, that we can have conditional statements within conditional statements, suddenly we can solve this problem. Because at this point, we are just finding the maximum between x and y. Have we talked about the logic to find the maximum of x and y? Yep, we talked about that before we talked about finding the maximum of 3 variables. So we already have the logic to do that. The logic to do that by itself is also a conditional statement. So I'm just going to draw the structure of a conditional statement first, and then we'll go back and fill in the details. Is that okay? Are there any questions of how do we connect the bigger conditional statement to the inner conditional statement? Nope. Okay. So inside the smaller conditional statement, now we have to say, okay, what conditions should I use here? Well, you can use, a variation of that, just to be consistent with the way we solve the problem of finding the maximum of 2. We'll just be using x is greater than y. We easily can flip the order, just flip the what you do inside the boxes. All right. So once again, as a conditional statement, it has one side labeled true and the other side labeled false. Okay. Does the inner conditional statement look any different from the outer conditional statement from the structural perspective? That it has one branch coming in, 2 alternatives, 2 ways to proceed, and then merge at the end. Nope, the same thing, right? Identical in terms of structure. It's just a smaller version of that. Okay. If we get to this part here, which variable out of these 3 is the maximum? We can conclude it is the maximum.
X.
X has to be the maximum. Okay. So that means z gets the value of x will solve the problem. What about the other one?
Y.
Y is the maximum. Z gets y is what we need to do there. Okay. What about this side here? What about the else side of the overall conditional statement? Well, we're down to w versus y. So that means we can solve that problem by using another conditional statement here. So, okay. And this time we have to compare w versus y. And just to resemble the logic on the other side, we can just name, we can use this as our condition. W is greater than y. So what if w is greater than y?
Z
Which
gets
one?
W.
Z gets w, because w is the maximum. Z gets w, and then the other side means y is greater than or equal to w,
So
and w is already greater than or equal to x. So on this side, we can say z gets y, and so this is the alternative to solve that problem of finding the maximum of 3 variables. This solution is kind of interesting because it doesn't use a multi-branch conditional statement. C and C++ natively does not have multi-branch conditional statements. Okay, you can kind of emulate a multi-branch conditional statement, but it really doesn't have one. So this will fit within a C program really well because I'm just using a regular conditional statement with 2 branches. It will even work without the conjunction operator. Because do you see the and word or the little TP symbol, representing conjunction anywhere? Nope. But what it does have is a structure. It has the structure of a overall conditional statement. On each side, on each branch of the overall conditional statement, we have a smaller conditional statement. Are we doing okay so far with the concept of putting a conditional statement inside another conditional statement? Now, when we talk about nested program or nested statements, the only statement that cannot contain other statements inside is an assignment statement. So an assignment statement cannot have components. All of the other types of statements can have components. So we are talking about a conditional statement, a loop, or the 2 types of loops. They can all have components inside. And there's no restriction as to what kind of statement can be embedded into what other kinds of statements. In other words, a conditional statement can contain a loop. A loop can contain a conditional statement. A loop can contain another loop, and so on and so forth. There's no restrictions whatsoever what you can put inside in the nesting part of this. Are there any questions about this picture? The questions? Any questions about what do we do when we walk through this picture according to this logic? The questions? So it's fairly intuitive that if we get to this branch here, we just have to enter this branch here. It's kind of like a room in a room, if you want to consider it that way. Or if you like a Star Trek: The Next Generation, a holodeck within a holodeck. Yep.
This would be a lot easier to do if we had actual numbers for the variables, right?
Absolutely. Well, let's do a trace using the picture first, and then we can do a trace using our usual way of doing things. Okay. So let's do let's say that you are holding onto a piece of paper. Okay, and on that piece of paper, it states the values of w, x, and y. Okay, and then we'll see how we're going to walk through this maze here. So let's say on this piece of paper, we have w equals to 4, x equals to 4, and z equals to 10.
You mean
Okay.
y?
See?
You mean y?
Oh, y. And z is unknown because the whole idea is to set the value of z using that logic. So this is a little piece of paper that you're holding on, and this is where you start. I can see someone writing a Scratch program, doing this, like the Scratch cat moving along. That'd be kind of cool. I should do it.
Or show your son it and have him do it.
Oh, that's right. I got a little child labor. Okay, so yep. So we'll go ahead and take a look at this picture here. Here's you holding on to that little piece of paper, and the paper, has this content. So what are we going to do to walk through this maze? Well, you get to this junction here, and it tells you, okay, let's do a comparison. Compare w to x. Okay, so you perform that comparison. 4, 4. Okay, is 4 less than 4?
No.
Nope. Okay, so where do you go? You go to this side. Okay, so once you get into this room, where do you go?
To the next
Check the next sign.
Yep, get into here. Okay, so well, when I draw this picture, I should have drawn it so that there's no other way, because somebody can say, but I can go around this whole thing and get out
There's
right
an
away.
opening right
No,
there.
you cannot do that. Okay. Okay, it's kind of implied, but I just want to make it clear that you cannot skip the entire thing. And here, that connects all the way here, which means you cannot just go somewhere else and sit on
Maybe
the lounge
lost.
here. Yeah, sit on the lounge here and watch TV. No, you cannot do that. Okay, so we get into here, and here's your next question. W is greater than y. W, y.
False.
Is that true or false?
False.
False. So that means you make the decision to go this way, and now you look at z. Well, it's nothing to evaluate anymore. You copy the value of y to z. So you say, okay, we know this value now. Go ahead.
So if you were to write out this algorithm, would it be like a if and then
I'll talk about that
if
next.
or
That's
else
next.
if?
That's a good question, because it's not just what it looks like, but how do you write it, the process of writing this in pseudocode. I'm going to show you that next. But before we do that, I'm going to go through this literal trace by going through the maze. So you perform that operation that says z gets the value of y, you erase this question mark, and you substitute with 10, and then what do? Well, I'm done with this. I'm getting out of here, and then I'm getting out of here, and I'm getting out of the entire program. Post. I'm done. Is that okay? I mean, does that kind of sink in? Okay. So the question now is, well, this is kind of cool, but we want to write this in pseudocode. We want to write this in a structured pseudocode. And once you can express logic in pseudocode that we use in this class, going from that to Visual Basic, C++, Perl, Java, Python, and whatnot is a mechanical step, because the structure of the code is already there. You're just trying to make sure that your program conforms to the syntax of whatever programming language you choose to use. You can do it in Scratch if you want to. Once we have the pseudocode, Scratch is like easy. Okay, so now that we have the structure represented by a picture, and we understand, okay, we have conditional statement inside conditional statement, how are we going to write this program? The way that I would do it, which is not necessarily the best way or the way that you want to do it, but the way that I would do it is something like this. When I write programs, I do it like this, without specifying any content. This represents the overall conditional statement, okay? But I'm not going to spell out the details. I will spell out the structure of the entire program first. So then I would say, inside the then branch of the entire program, I have, guess what? Another conditional statement. And inside the else branch of the outer conditional statement, guess what? We have another conditional statement. Okay, so this is the way I would do it. And also, for those of you who want to remember this picture and you didn't draw it, you can take a picture of it. If you want to use a cell phone, take a picture. That's fine with me. All right, so once I have spelled out the structure of the entire program, then I will go back in and fill in the details. Why do you think I write a program like this instead of starting with line 1 and then just go sequentially?
Kind of gives you more thinking about it, more logic to it.
Because it reflects the structure first. Okay, it's just like when you're writing a longer, English, paper. You don't just start with the first sentence and be able and expect that you can finish like a 5-page, paper just by writing sequentially, right? Most people would structure the article first. Okay, the first portion needs to do this, okay, but not specify any detail. The second portion needs to address this, but not without details. The third portion, this, and then we have a summary. And then within each section, then you will start to outline. Okay, now I need to first talk about this, then I need to talk about this, then I need to talk about this, but without the detail again. So I'm doing exactly the same thing. If you want to use the file structure, folder structure analogy, all I'm doing here, with the pseudocode up there, is to set up, okay, I need to create a subfolder for year 2014. And then within year 2014, I'm creating one subfolder for each month. That's what I'm doing. I'm just creating the slots so that I can fill in those slots later on. Are there any questions? Now, if I use this approach, there are certain things I don't have to worry about. In other words, I don't have to worry about, where am I supposed to put the end if of this statement? There's no need to worry about it. I don't have to worry about forgetting to put an end if, because I write the 3 lines together. If, blah, 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 then, else, and if. I don't proceed until I have the entire structure of a conditional statement and then I go in and specify more detail. So there are certain advantages to this approach. The only disadvantage of this approach is I have to use the cursor keys to move up and down a little bit. But from my personal experience, the cost of having to move up and down a little bit is easily outweighing the fact that I don't have to worry about where is the ending of a particular construct. So for me, it works really well. And I can talk about how this translates to C, but I'm going to finish this first, and then we'll take a look at the equivalent C code of this program. So at this point, I'm just going to copy the code that I have already on the whiteboard. And this one is x is greater than y, and then here we have x is the maximum, so z gets x, z gets y, and then here we compare w to y, confirmation that w is the maximum, and confirmation that y is the maximum. And there we have the entire program. Are there any questions about the process of converting the pictorial representation of this logic into actual pseudocode? Now, as I said, once you can get to the pseudocode, translating that pseudocode into a particular programming language should be a fairly mechanical process. So you can translate that into C, C++, Java. Now, those 3 languages are so close to each other that they actually look identical when it comes to something like this. But if you like to program in Visual Basic, this is almost Visual Basic compliant code. I think the only part that doesn't work would be the assignment statement, not using the single equal symbol. And if is one word, if I remember correctly, in Visual Basic. Those are the only things that would not work in Visual Basic. Now, if I were to translate this into C, I just want to give you some exposure to the C syntax. The C syntax looks like this. The condition has to be inside parentheses. It doesn't have, it has else, but it doesn't have the concept of a then. And then it uses curly braces to indicate the beginning and the end of each branch. And there's no explicit end for the entire conditional statement. So there's no equivalent to end if that we use in this class, which definitely can cause problems. Okay, I personally think that a conditional statement should have a definite end for the entire construct and not just an end to each branch. But that's the way C is set up, and we don't really get to choose how to get C to work. So inside here, I would use exactly the same thing. I open the curly brace, I close the curly brace right away. So this way, I don't have to worry about, oh, did I close that curly brace later on? Whoops, I forgot something here. Forgot the else. This editor doesn't have an auto indentation, but with auto indentation, it's a lot quicker to type this. So I would write this out in C first, and then I go back in and fill in the detail. I'm not going to do that step because it's going to be quite boring. It's going to be about the same thing. But I would do the same thing, when I write programs in C and C++ and Java, is open the curly brace and immediately close it, so I don't have to worry about, closing a curly brace. The other thing is, if you use an editor that has auto indentation, the closed curly brace is going to be at the same indentation automatically. So you don't have to later on figure out, okay, which open curly brace am I closing here, and what is the indentation level? I don't have to worry about that again. So just personal experience, I just personally like to write my programs in this fashion. Whether it fits your particular programming habits or not, it's entirely up to you. But for me, it works well. Okay, any questions? No question? Yep, go ahead.
Sorry, this is not part of class. What compiler do you recommend
For
just regular coding Java?
For Java? For Java, you can use Eclipse. Eclipse is what we call an IDE, an integrated development environment. Eclipse is used in industry a lot, so if you know how to use Eclipse, it can only help you, in an interview. It's also very convenient. You can have different types of plug-in to Eclipse to fit the specific kind of programming that you're doing. If you do any type of Java, Android programming, you can get an Android plugin for Eclipse. So that way you can actually design your screens in a more WYSIWYG fashion. You can look at the XML files in a much more intuitive way. So Eclipse is really good for Java type of projects. If you're dealing with C and C++, which many of you will have to kind of learn in the next class, Code Blocks is one, and the other one is Dev C++. These are all free products. These are all your products that you can download and install for free. So it just kind of go there a little bit. This class is a little bit ahead of the other class, so we kind of have some time to talk about these things. So one is called Code Blocks, and it's kind of written in a very funny way. Code Blocks. This is a IDE for C, C++, and Fortran, but most people don't program in Fortran anymore. But it's really kind of good because it's lightweight by comparison. Eclipse is kind of heavy duty. This one is relatively lightweight, and it's used in our own cisp300 classes, so it's a good tool to use. Another one is called Dev C++, DEV C++, by Bloodshed Software. And it's about the same. If you look at the screenshot, it looks kind of similar to the other one. And once again, both of these are free software. Yep.
Master sheet.
Oh, sorry?
Roll sheet.
Roll sheet. Yep. Okay. So I want you guys to fill this in.
What's the name of that one? Dev C++.
Yeah, dev dev C++. Dev C++ is a dev C++. For those of you who want to program in Java, then you want to look into Eclipse. So that's the home page of Eclipse. It's open source, so that means you can download and install it for free. Let me see if I can find a screenshot of that. Yep.
What was the name of the one that had blocks in it? The second one you showed?
Code
Code
blocks.
blocks.
CODE and then colon and then blocks. But Eclipse is mostly for Java developers. So if you program in C and C++, you should use the other two. Okay. Good questions. Any other questions? Nope. Okay. So the next thing we want to do is to trace the algorithm by coding it in our pseudocode, and then we'll go ahead and trace it in pseudocode. So once again, it's not as easy for me to use the same approach when I'm dealing with the spreadsheet, because in the spreadsheet it's much harder to insert additional lines. I will show you exactly what I mean by that. So if I want to use the same approach here, saying if open paren, close paren, then else, and if, then when I want to insert something, I have to go here and then just keep clicking, insert rows above. So that's why that approach kind of backfires when I have to do my program inside LibreOffice. Yep.
Is there a hotkey for that, or do you have to click it? Click it.
You can program a hotkey if you want to. That would be handy, but it doesn't have that natively. So here is a little bit different, because I have to go through a little bit more trouble to insert additional lines. But the other thing that's nice is, I can leave enough space in between because I already know the structure of the program. But otherwise, it's not really as easy to deal with. So now I have to do the same thing here: insert, 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 insert.
A little more tedious.
Yeah, it's a lot more tedious than using a text editor. And of course, I could have just copied and pasted. And
That's a bad habit, though.
yeah. But the nice thing is I can select multiple cells and then do the indentation all at once. So that part is
How do you do that again? I can't remember which.
Control click.
Control click.
Yep. With most programs, either control click or shift click will allow you to select
Yeah, I
multiple
was
items.
trying to do that on the portable version, but I wasn't getting really any results.
Yep. It's control click in this case. Here we have Z gets X. Z gets Y. And then we have W versus Y. Z gets W. And Z gets Y. There we go. So that took a lot longer because of the way a spreadsheet works is different from a text editor. All right, so let's go ahead and trace it. Okay, so we'll trace this using exactly the same example so that we can just compare the two approaches. So we have comments, line number W, X, Y, Z. We can shrink the columns. And make this one smaller. There we go. All right. So to represent exactly the same thing that we did on the whiteboard, we'll have the values exactly the same as well. So we have 4, 4, 10 in W, X, and Y. 4, 4, 10. Z can start with an unknown value, and that's my precondition. All right, so now we have everything set up already. We have the picture on the whiteboard and the trace also on the whiteboard, and we will do it in pseudocode on the projector at this point. Starting with line 1, we evaluate X is less than W is less than X is false. So where do we go? Okay, when the condition of a conditional statement is false, we go to the else branch. So the question now is, how do I locate the else corresponding to the condition that I'm dealing with right now? Because you can see there are like 3 else's in the entire program. So which else applies to this condition?
Does it say line 7?
How can you guys so quickly point out it's line 7?
It's not indented.
It's not.
It's
Well,
at
it has
the
the
same
same indentation
indentation.
level as the line that I'm on at this point, right? I mean, what you said was correct. It has no indentation, but that's only because the line that we are on also has no indentation. So that's why it's so easy to locate it. Now, what would happen if I do not have indentations whatsoever for the entire program?
A lot harder to find it.
Exactly. It will be harder. It's not impossible to find it, but it will be harder. So that's why indentation is useful, because it let us visually spot the corresponding structure, the end or the alternative of the corresponding structure. So now that we know that the line 7 is indicating the else of this statement, but remember, we don't trace line 7, it's just else. So we trace line 8 instead. Line 8 has one comparison, y is greater than y, w is greater than y is
False.
also false. So where do we go? We go to the else that has the same indentation as line 8.
Which would be 10.
That would be 10, but since we don't trace line 10, we go straight to line 11. Yep, exactly. So we trace line 11 at this point. Line 11 is just an assignment statement. So we look at the value of y, it is 10, then we copy that to z. And then where do we go?
Post.
And
We go all the way to post. That is correct, because line 11 is the last thing, the only thing we do inside the else branch of the smaller conditional statement, starting on line 8, ending on line 12. But that conditional statement is also the only thing we have to do inside the else branch of the outer conditional statement. So that's why we are getting out of, when we get out of here in the picture, we go straight to here, and then we go straight to here. And that's why we go straight to post without going through, without indicating line 12 or line 13, because we don't trace and if in this class. Are there any questions about that picture? The picture and the pseudocode representing the logic of the picture. How about the process of constructing the picture to begin with? The logic. Yep.
I have a question actually.
Go ahead.
If you can repeat again why we go to line 8 afterward.
Okay. Well, let's go ahead and try to label, the line numbers in the picture, so we can correspond the pseudocode to the picture. Line 1 is easy, okay? That's the entry point of the entire program. Line 2 is represented here. Line 2 is the beginning of one of the nested conditional statements. Line 3 is corresponding to the statement that we execute when the condition of the inner conditional statement is true. Line 4 has no representation in this picture, because all it's doing is to serve as a separator between the then case and the else case. Because without the else word on line 4, I would not be able to distinguish which part is the then portion and which part is the else portion. So that's why else has basically no representation in this picture, other than we have 2 blocks here. But I cannot point out one place and say, oh, this is line 4. But line 5 does. Line 5 is the action that we perform in the other branch. Line 6, technically, you can kind of look at this as line 6 because it is at the end of the inner conditional statement. What about line 7? Again, it has no true representation in the picture because it is just there to separate the 2 portions of the outer conditional statement. So line 7 has no representation. Line 8 is the beginning of this inner loop. Line 9 is the action that we perform for the then branch. Line 10 has no representation. Line 11 is the else action of the inner conditional statement. Line 12 is the end of the inner conditional statement. Line 13 is the end of the outer conditional statement. So if you want to kind of map the line numbers to places of the pictorial representation, that's kind of the way we do it. And that's why, after we evaluate the condition of line 1 to be false, we go straight to line 8. Any other questions? Yep, that's a good idea, taking a picture.
A lot easier than having to write it all down.
Any other questions about this? I'm gonna just let this one stay on the whiteboard. So for those of you who want to get a close up, you can walk up to it. After the class ends, you can do the human zoom. How many cell phones have a zoom feature? How many people have a cell phone that has a zoom feature? Is it optical zoom or digital zoom?
Digital.
Digital.
Yeah, it doesn't protrude.
Okay.
That would be pretty cool.
I think some cell phones start to have
I think it's
optical
like the
zoom.
1020 version of with Nokia Lumia. It has
Okay.
The whole camera setup, 42 megapixels, I believe.
42
Yeah.
megapixels?
Yeah.
Yeah.
It's a beast as far as camera phones go.
Or you can buy that attachment thing on iPhones. You can
yeah.
actually buy attachments. You can turn it into a spy phone, right? Because you can have 8
Like
times,
Austin
10 times
Powers,
magnification.
which movie that was.
Yeah. Or you can just get a little monoscope or monocular, and then just put your phone behind the monocular and try to line up everything.
Perfect.
That works too.
Get your duct tape out. Duct tape fixes everything.
Between that and hot glue, yes. All right, so I think we have a fairly good idea of what a nested statement is at this point. So if I go back to my notes, I think we are ready for this. Well, we are already in it. Let me just kind of go back here. The first one is a very simple example. You look at this code here and go like, wow, we have done this just at the beginning of this class. Is that really a nested statement? The answer is yes, it is a nested statement, because line 3 is a statement. It is an assignment statement, but it is inside a while statement. From line 2 to line 4 is a while statement. So line 3 is a statement that is nested within another statement. So that's why we have been talking about nested statements for a while. I just did not call that nested statement because it's a very simple statement inside another statement. But now that we have constructs like this, where we have a compound statement inside another compound statement, then we can start to construct more complex logic in this class. So the more complex example looks like this. Doesn't look too complicated when you look at the pseudocode, but if you try to draw a picture representing this, it is quite a bit more complicated. Okay, so this time we have a loop inside another loop, and there are two things that we have to do. We have 10 minutes remaining. I think we can at least get started with this one. So with this condition, with this pseudocode, what we want to do is, one, we want to kind of find out what the logic is really saying and how to draw the picture. And then the second thing we want to do is to trace it to find out, okay, when we trace this, what is the behavior of this kind of difficult, complex code. When you draw a picture like this, how do you start with this picture? If you want the picture to look good, you draw the picture from the inside out. Okay, because that's the only way that you know that you reserve enough space, right? If you want to do it in the structural way, you want to draw it from the outside in. So it all depends on what is the purpose of you drawing the picture. So I'm going to draw it from the inside out, just to show you the other approach. This picture of the conditional statement, I drew it from the outside in already, so you kind of know that process of reasoning it out from the outside in. So with this one, I'm going to draw it from the inside out. If I want to draw this pseudocode algorithm too from the inside out, where do I start? What is the innermost part of this algorithm? Lines 6 and 7. How do you know it?
Because it's indented the most.
Right? Just visually, it is indented the most. Okay, very good. So that means indentation, once again, is useful, right? Do you think it is so, because indentation is so useful to us as human people, developers, do you think the compiler thinks it is useful too?
Yeah.
No. Most compilers do not care about indentations or even the new line characters, okay? Which means if I go back to my previous example here, looking at the C code here, if I turn this entire program into one single line, like this, oops. Come on, let's continue. Well, you get the idea. Okay, so now I have just turned the entire structure of a conditional statement inside another conditional statement onto a single line. The C compiler can compile this just fine, as opposed to the original form. In other words, new line, the concept of having a new line, and also indentation, they have no meanings whatsoever in C and C++. Well, would you want to read a program like that, especially with content, like specifying comparison and assignment statements and stuff like that? Probably not. Okay, so I just want to point out that compilers do not care about indentation. Indentation is really for your convenience. Yep, go ahead.
Is that specifically just for C, or is that for both languages?
The only two, in Python, new lines and also indentations are both important. So in that case, indentation is the only way you can tell, is this inside another construct or not. In Visual Basic, there are only so many things you can put onto a single line, so new lines are important in Visual Basic, but indentation is not. In a visual program, you can use any indentation you want, and the basic compiler basically does not care. Okay. All right, so getting back to our example here, just from indentation, we know lines 6 and 7 are the innermost portion of this algorithm. So I will start with that. So we say y gets y plus 1, and then we have s get s plus x equals y plus x. Okay. And that belongs to where? Line 6 and 7 is a part of what? Of a while loop. Okay, so we'll go ahead and draw the picture of a while loop surrounding this logic here. Okay, so the picture of a while loop, I'm not going to have enough space to do it. I know already. Okay. This is the overall shape of a while loop, right? So now we can add the condition of the while loop here, which is y is less than 2. Label this path false. Label this path true. So now we have the inner while loop, which is from line 5 to line 8. And then what do? How do we step one step out? One step out. Oh, we're not ready to go one step out yet, okay? Because we have to take care of line 4. So line 4 is immediately before the loop here. So line 4, should be here. It says, y gets a value of 0. And then we have line 9, which is right after the loop, which is down here. X gets x plus 1. Are we still doing okay so far with this picture? Okay. And then this whole mess is from line 4 to line 9, but that chunk of line is inside another loop, right? I don't have enough space to do the whole thing, so I'm going to cheat a little bit and say that this whole thing becomes what I call block A, okay? So I have now block A here, and what is block A inside? Inside a while loop, right? So that means I have to draw another picture of a while loop. Okay, so we have a branch all the way back to the beginning. And a way to branch out of the loop. Label this one false, label this one true. And the condition is x is less than 3. All right. There's nothing after the outer loop, but there are two statements before the outer loop, which is x gets 0 and s gets 0. So then we have x gets 0, s gets 0, right before the outer loop. So that's the way I would draw this picture. Now this picture you don't have to copy because later in the notes on this page, there is a picture already.
Oh god.
with different portions already highlighted as well. So, and you can see that I drew this pretty much by hand too. You know, it looks really kind of homey, kind of DIY-ish. Yes, I know you guys. This is really ugly, right? Coming from audio media. But it does show the logic of the whole thing. I mean, it has the little bubbles. This is the inner loop. The gray portion is the inner loop. This is the one statement after the inner loop. This is the one statement before the inner loop. But these things combined become the portion inside the outer loop. And there are things that I have to do before the outer loop as well. So that picture is the same as what I drew here on the whiteboard. It's just that on the whiteboard I didn't have enough space. I have to break it up into two portions. Whereas in the notes, I was able to fit everything into one single picture.
So, say x is already false, say if you put 3x equals like 4, then y never gets assigned.
That is correct. Yep. But this program does initialize x to 0 to begin with. So that's why we are guaranteed to get into here, get into the block A, and initialize y to 0 before we get into the inner loop. Okay. Now in the notes, so what you want to do over the break, I know you guys have a long weekend, like really, really long weekend. So that means, I know that you have time to read, at least finish this particular note here. This is a partial trace of this algorithm. Not as a homework assignment, but rather, as something that I want you to do, so that, next Tuesday when we come back, we can continue with this discussion. I want you guys to finish the trace. Okay, this is, the beginning of the trace. It kind of shows you, how to proceed from one point to the next. So I want you guys to finish this trace just so that you have some practice of dealing with nested statements. And after nested statements, that would be the last topic of topic 2. But from topic 2, we'll be moving on to topic 3. When you look at topic 3, it talks about pre and post conditions. So compared to topic 2, topic 3 looks really simple, right? There's only one link in it. Okay, but that one link is going to be more complex. There will be more discussions than the entire topic 2. Topic 2 is easy because it's very hands-on. Okay, we can look at the picture, we know how to follow it. We can just go, okay, I'm here, now I make a decision, I go there, and so on. Topic 3 is entirely different. It is a proof kind of thing. If anyone in this class like mathematical proofs, you will like topic 3, because topic 3 is just about that. If you do not like that, then you're gonna hate topic 3, but it is an important topic. So read ahead of me, read into topic 3 a little bit, and then next week we'll continue from here.